We now continue with the chapter acid, bases and salts. Uh, in the previous two videos of this topic, we had understood that what are acids, what are bases, what are alkalis. We also learned how the preparation of acids and bases takes place by the different methods. We also learned about the different classifications of acids and bases, so how they are classified as strong, weak, concentrated, dilute and so on. uh, and there were some few kind of doubts also coming up that what's the difference between the strength and concentration. So please understand that acid, when it is concentrated or dilute, it has nothing to do with its strength. The strength is not dependent on the number of water, of the amount of water present in that acid. It is dependent on the dissociation of the hydrogen ions over there to form H3O. If the dissociation is getting complete dissociation, then it's a strong acid, and if it is going to be a less amount of dissociation of hydrogen, that H3O formation, then it's a weak acid. It has nothing to do with the concentration, that is dilute or concentrated, say. It is not going to become strong or weak. Okay, just wanted to clarify this thing. Now we move forward. So we also learned about the physical properties of acid, that acids were sour to taste, they were mineral acids, are highly corrosive, and the indicator used was litmus paper. So litmus paper, the blue turns red in case of acids. Similarly, for physical properties of bases, they are bitter to taste, caustic alkalis are highly corrosive in nature, and the red litmus turns blue when you are seeing the litmus test for bases. So that was what we did the last time. Now we come to the chemical properties. So chemical properties are that general properties. Now chemical properties, mainly we'll be having one by one of acid and bases. So the first and foremost chemical property what we'll be using for acid will be neutralization. So the first one, so chemical properties, so we have over here chemical properties. What do you mean by chemical properties? It is how they are going to perform, how are the acids going to react with other substances, and what will be the resultant of that kind of a reaction. So these are very important. See, chemical properties of acids are very important, because once you know the chemical properties of an acid, automatically all the acids which are behaving as normal acids will have a similar property. So I don't need to learn separately for HCl, separately for H2SO4, separately for HNO3. मुझे अलग learn करने की जरूरत नहीं पड़ेगी, because these are common kind of general kind of the chemical properties what is going to be there for all the kinds of acids. So then what will happen is that once you learn this, if you are learning HCl, you are only learning those typical kind of equations over there, typical kind of chemical reactions over there, which are not general form. They are only unique for HCl, unique for H2SO4, unique for concentrated, unique for dilute. So that part you can learn it as a separate thing, but the general thing you will come to know by this chapter itself. So that's why we go one by one with the chemical properties, that is the how the acids are going to react when they come in contact with certain kind of substances. The first one is called as the neutralization reaction. So neutralization reaction is the one which is going to take place with the base. So it is when the acid reacts with base, what will happen? So it is acid plus base will give you salt plus water. This is the most common kind of the formula of chemical reaction which is going to take place with acids. Acid plus base will give you salt plus water. You have been studying this thing since I think the last 3 years. So a very easy thing and you know it very well. Example, this would be if I take an acid, let's take an acid to be HCl and the base to be the CuO, then it is going to give you over here CuCl2 plus H2O. Okay, so you can balance this equation. This is just 2 over here, that's it. That will balance automatically. So CuO plus HCl gave me CuCl2. So in case this is an acid, it's a base, a salt and water. You can have another example over here which will be HCl plus NaOH giving me as NaCl plus H2O. Okay, so that is how we are going to have acid plus base gives you salt plus water. You can have acid over here as H2SO4 also, doesn't matter. This will give you CuSO4 in that case. So it is just going to just be like this. So nothing different here. Every time you are going to get the same kind of thing. Whether acid HCl or H2SO4, it doesn't matter. So you see that acid plus base will give you salt plus water. That is the first one. Now we come to the next one, and that is reaction with active metals. Acid with active metals. So what happens when acid reacts with active metal? So we see an active metal. Let's take Zn as an active metal. It is reacting with HCl. Now we very well know that H and Zn. What is the position of Zn with respect to H in the reactivity series? In the reactivity series, we very well know that Zn is up and H is down. So Zn can easily kick out H from HCl and replace it. Hence we get a ZnCl2 plus H2 gas. So this is how the reaction takes place, that whenever an active metal reacts with an acid, hydrogen gas will be released and a salt will be formed. So it will be salt plus hydrogen gas. Okay, so active metal, so it is active metal plus acid will give me salt plus hydrogen. Okay, that is the second important chemical property of acid. We now move on to the third one. The third one is the reaction of acid with chlorides, nitrates, bicarbonates and carbonates. Okay, so we'll go one by one. So that means you are here taking a, so the third one is acid with salts. Salts of what? Chloride, nitrate, carbonate, bicarbonate. Okay, these are the different kinds of acid things we are going to use it. So first thing, what is going to happen is salt reacting with acid, it is going to give me a metallic salt. So this is a salt. The salt is going to become a mixed salt over here. So it is going to give me another salt over here, and it is going to give me another acid. So that is given over here as another acid, or it could be acid, or it could be, or you can consider this as gas or acidic gas plus water. Okay, let's see the example so you'll understand it better. We have the example of NaCl, a chloride. We are taking an example of chloride which is reacting with H2SO4. We very well know over here that when Na will react with this thing, it is going to form, it can form what easily will be NaHSO4. Now this is because we are not going to heat it too much, so you are going to have a temperature which is less than 200 degrees Celsius. So it will be NaHSO4. If the temperature would be more than 200 degrees Celsius, it will become NaSO4. But right now we will not think about it. We just consider it as you are going to be replacing one of the H from here, and that is going to give you over here HNCl, so it's HCl. So that's why we say that salt plus acid is going to be formed in this case. Got it? So salt plus acid will give you another salt, okay, over here, which is a salt 2 plus acid. So that is a double displacement taking place over here. Cl going here, SO4 going here, HSO4 going here. That's a double displacement reaction. Similarly, if it is NaNO3 plus H2SO4, again at a temperature less than 200 degrees Celsius, you are going to get the same thing, NaHSO4 plus HNO3. That's an acid. Okay, HNO3, NaHSO4, double displacement reaction, simple form that chlorides are going to give me another acid. So chlorides of the salt is going to help me in generation, or chlorides or nitrates are going to help me in generation of another kind of an acid over here. Okay, so if I want to produce this and this, I will use a nitrate for this, and chloride ke liye I'll use sodium chloride. Now we come to the next one, it is carbonates and bicarbonates. So let's see a carbonate and bicarbonate. So first let's say there NaHCO3, a bicarbonate, plus H2SO4. You're going to heat it and you get it over here, Na2SO4 plus carbonates will always give me 2 acidic gas, that is CO2 plus H2O. You can balance this equation by putting a 2 here, 2 here and a 2 here. So what is the importance thing over here? That whenever, see, this could have given me an acid. H2O plus CO2 gives me an acid, but it's an unstable acid. That's the reason whenever you are going to add it up, even if it is not pressurized properly, it will turn out into carbon dioxide with water. That is precisely what is happening in your all your aerated drinks. Thumbs up वगैरह में क्या होता है? Under carbon, it is carbonic acid inside, but the carbon dioxide is getting released because it was under pressure. Carbon dioxide is getting released. So the same thing happens over here. Carbon dioxide and water, they will need to be under pressure so to form a carbonic acid. Otherwise you get an acid. Not that you are not getting an acid, but ये pressurized नहीं है, unstable है, इसलिए वो split up हो जाता है. So it gives me a bicarbonate with an acid will give me a salt plus here in this case CO2 plus H2O. So here we can always remember this as a thumb rule that acid when reacts with bicarbonate, it is going to give me carbon dioxide gas. So it will give me salt plus water plus carbon dioxide. Okay, acid plus carbonates or bicarbonates. Even carbonates also gives the same thing. We'll just write that thing also so that it is clear. Na2CO3 plus H2HCl. We'll stick HCl. Yeah, we can use any of them. We're giving NaCl plus CO2 plus H2O. Okay, this is going to be 2, so 2 here, that's it, and 2 here, so H2, H2, yeah. So you see over here that carbonates or bicarbonates, whenever they are reacted with acid, it is going to give me salt, a kind of a salt plus water plus carbon dioxide. Okay, salt plus water plus carbon dioxide is what I'm going to get with carbonates and bicarbonates. If I'm using any other kind of salt like chlorides or nitrate, I am going to get the respective. Chloride use किया तो hydrochloric acid मिलेगा, nitrate use किया तो nitric acid मिलेगा with the salt being formed. This salt will be formed at a temperature less than 100-200 degrees Celsius. If it is more than 200 degrees Celsius, it will decompose into bisulfate के पहले sulfate हो जाएगा. Otherwise, everything remains the same. Okay, so that is the formation, or you can say the general properties of acid. So acid के general properties are 3 properties. First property, neutralization. acid plus base gives you salt plus water. Very important. Second one, acid when reacts with active metals, they will give you salt plus hydrogen gas. Hydrogen gas will be released and salt will be formed whenever an active metal reacts with an acid. Third thing, salt reacting with acid. So salt plus acid will give you salt plus acid only, but only double displacement taking place. So accordingly, what will happen? A chloride salt will give me chloride acid. Nitrate salt will give me nitric acid. Whereas carbonates and bicarbonates, they cannot give me acids because they need, for acid, they need high amount of pressure now. That's why they are just going to give me water plus carbon dioxide. So hence we see acid plus bicarbonates give you salt plus water plus carbon dioxide. So that was the one which was the chemical properties for the acids. Okay, so here it is mentioned, which is very important to understand, and this a less volatile acid one, that is the less volatile. Now this is concentrated H2SO4. This is going to be concentrated. Okay, concentrated. A less volatile. The concentrated H2SO4 is a less volatile acid. So concentrated H2SO4 has got volatility is less. That means the reaction is slow. And because the reaction is slow, it is able to give us this particular kind of a thing. When the reaction is very fast, then it is not able to perform and give you a particular acid. It will be such that it is just going to decompose. So that's why over here we can see that when you are using a concentrated sulfuric acid, you are going to get, that means it is given over here that the less volatile acid 1 displaces the more volatile acid 2 on heating with salt. So this is displacing this one. So this is forming this one. Okay, this is helping to displace NO3 and give you HNO3. This is a less volatile giving you a more volatile acid. Less volatile acid forming a more volatile acid. Now these equations are very important because they are used in the chapter HCl as well as HNO3 for the preparation of HCl and HNO3. Okay, so very important. Now we move on to the chemical property of bases. So chemical properties of base now. Okay. So in bases we have first, it is a test for OH ions. So test for hydroxide ions in the solution. So alkali reacts with ammonium salt on heating to liberate ammonia. So that is the first thing. And accordingly you have the first also thing as again here. See, neutralization here also it happens. Acid plus base gives you salt plus water. But here if you take a ammonium salt, okay, then it is going to be slightly different. So here the first thing is that a less volatile base, that is NaOH, okay, for example NaOH displaces a more volatile base. So NaOH is less volatile and NH4OH is more volatile on heating. So it is going to displace, NaOH is going to displace NH4OH when it is, so here we have got over here the ammonium salt plus base, that's base 1 which is less volatile, will give you a salt. Okay, it is going to give you a salt and salt 2 and plus it is going to give me a base 2. Now this base 2 will be this way, so it is ammonium salt, it is NH4Cl if it will take, plus NaOH will give me double displacement NaCl plus NH3 plus H2O, which can be written as NH4OH. Okay, so NH3 plus H2 will give you NH4OH. That's why we can write this way also or this way also. Both are correct. So it is ammonium salt plus base will give you salt plus another base in this manner. So that is the formation over here. The next formation is, next chemical property is, alkalis react with certain metallic salts solutions to precipitate. Now this is one of the most important point of bases. Now in this case especially the two bases NaOH, which is the non-volatile one, and NH4OH, which is a volatile one, they, when they react with salts, at that time they are going to form the respective metallic hydroxides. And the main advantage over here is that the respective metallic hydroxides over here will have a proper color, and they will be insoluble. So there will be insoluble hydroxides, that means the bases, which will be formed, which will be colored, and because they are insoluble, so they will precipitate down, and that is the reason the color of the precipitate will identify that particular metallic salt or metallic part of the salt. So that's the reason this particular kind of the equation what we are learning now will be used for analyzing that what kind of metal was present in that salt by giving you the color of the precipitate. So let's take an example over here. The first thing what we write is the general formula, that metallic salt plus base, which will be an aqueous base, of course, aqueous solution, will give me a salt plus an insoluble hydroxide. Okay, it is going to give me a metallic salt plus base will be salt plus insoluble hydroxide. For example, CuCl2 plus NaOH is going to give me NaCl plus CuOH twice. Okay, so balancing here. Now this is the important part. Here CuOH twice is a precipitate, and the color of this precipitate is going to be blue. So that is a blue PPT. This is identification for copper. So when I get a blue PPT, so I got some salt in with me. Okay, I said pour some NaOH aqueous solution into that salt. एक टेस्ट ट्यूब लिया, उसके अंदर थोड़ा ये पाउडर डाल दिया था मैंने. Okay, that powder is inside. I put some NaOH in it and then I leave it. So what will happen? The reaction starts. After some time you will find that there will be a blue colored precipitate at the bottom. Once I get that blue colored precipitate, I will come to know that the salt which was used was of copper. Okay. If the color would have been, let's say, white, it could be zinc or lead. If it would have been dirty green, then it would be like ferrous. Okay, if it is reddish brown, it is ferric. So that's why there are different colors of the different metallic hydroxides which can help us to identify that particular metal. So the next one is FeCl3 plus 2 I'll write directly later, NaOH is going to give me 3NaCl plus FeOH thrice. So this is Fe3. Fe3 is nothing but, it is ferric, so it is brick red. So it is reddish brown. It will be red brown PPT. So the PPT will be reddish brown. Similarly, we can have ZnSO4 plus 2NaOH will give me Na2SO4 plus ZnOH twice. This is going to give me a gelatinous white PPT. All these are PPT, will be shown as a down arrow here. Very important to show the down arrow here. Over here you can write over here aqueous. This is AQ, aqueous solution. So that's how we are going to write these equations. So we see here that the chemical properties of bases was helping us to find out the type of metal being present in that salt. We have some short thing about the formation of acid rains also. So acid rain refers to the rain or any precipitation of snow or fog which is acidic in nature. So if the pH value of the rainfall which is there, so normally the rainfall will have a water in it, so it will be neutral, so the pH value will be 7. We'll just learn about the pH value a bit later, maybe in the next video. So if the pH value is towards the acidic part, so it is 5.6 के आसपास में, then it is called as an acid rain. It is generally complex mixture of sulfuric acid along with sulfurous acid, nitric acid, and along with nitrous acid. So this is a combination of 4 acids. See, basically what happens is nitrogen and oxygen both are present in the nature, in their atmosphere. So because presence of nitrogen and oxygen is there, there will be formation of nitrogen dioxide and nitrogen trioxide in the atmosphere due to rainfall, due to lightning and all. So this nitrogen dioxide is going to form nitrous acid, and nitrogen trioxide will form nitric acid. So this way nitrous acid and nitric acid is going to be formed in the atmosphere due to lightning. Same way, the exhaust of the anything, when you burn any kind of a fuel, you are going to get certain amount of sulfur content which is given out. The sulfur content which is given out will form sulfur dioxide and sulfur trioxide, which will in turn, when rainfalls are there, so H2O uske sath milke, it is going to form sulfurous acid and sulfuric acid. So that's why you have got sulfurous acid, sulfuric acid, nitric acid and nitrous acid present in the atmosphere during rainfall. And that is nothing but the acid rain. It is caused by atmospheric pollutants, mainly sulfur dioxide and nitrogen oxides. Acid rain depletes the soil of the nutrients, increases the acidity of the soil and reduces fertility of the soil. It destroys marine life due to change in pH of the environment and also causes material damage. So these are the different problems of acid rains. Over here. The next is, so formation of acid rain is given over here, that it is S plus O2 is SO2, so we can just quickly go through it. In fact, we had gone through this same thing about when we had done the preparation of acids, so we are just going to go through quickly with this thing. So it is like S plus O2 giving me SO2. So whenever the fossil fuels are burned, SO2 is going to be released in this form because sulfur will be part and parcel of the fuel. So S plus O2 will be SO2. And then this SO2, H2O plus SO2, which will be the water will be available in the nature in the form of water vapor. So that is going to give rise to H2SO3. That is nothing but the acid. This is an aqueous solution. So that is aqueous form. Similarly, there could be possibility that SO2 further gets oxidized to SO3. So it will be SO2 plus O2 giving me SO3, and this H2O reacts with SO3 to give me H2SO3, SO4. Balancing of this will be 2 here and 2 here, and H2SO4 SO3 is direct combination. So that is how you are getting to get the aqueous solution over here of sulfurous and sulfuric acid. Similarly, you get, so this is how we are getting acid rain of sulfurous and sulfuric acid in nature, that is acid rain. The next thing could be that N2 plus O2 giving me 2NO. So it will be 2NO which will be formed due to lightning. So very high temperature lightning, when it is striking in the air, it is going to be giving rise to the nitrogen and oxygen in the air to get mixed together to form NO. And so in this particular way you are getting NO, and this NO, when it gets further oxidize, it becomes NO2. So it becoming NO2, which is 2NO2 over here, and this 2NO2 when it reacts with water will give you this thing. So it is going to be H2O plus NO2. Now here in this reaction both the things happen simultaneously. So it is going to give me HNO2 plus HNO3. This is a reaction what is going to take place because this is 2 over here. So this NO2 is going to react with water to form this also and this also at the same time. So one O goes over here to give you HNO3, and here without that one H will be forming HNO2. So this way nitrous and nitric acid both are going to be formed during acid rain. So that was about the formation of acid rain. The next what we have is uses of acids and bases. So acids are used for eye wash, boric acid, that is eye wash. Of course, these all will be weak acids. Food preservative, citric acid. Ink stain remover is oxalic acid. Flavoring the drinks, that is nothing but the aerated drinks, thumbs up and all, that is carbonic acid. Baking powder is tartaric acid. Cooking is vinegar, that is acetic acid. And pickling of metals, that is cleaning of the metals from the rust and all, that is hydrochloric acid. In the bases, the manufacturing of soaps, you are using sodium hydroxide. Manufacturing of bleaching powder, you are using calcium hydroxide. As an antacid, that is the one which is nothing but ENO, what you have when you have acidity. So that what you take is nothing but magnesium hydroxide to neutralize the acidity in your body. As a fire extinguisher, it's hydrogen hydroxide, aluminum hydroxide, which is as a fire extinguisher. Softening of water is calcium hydroxide, and removing grease stains from clothes, it's ammonium hydroxide. See, that the uses of acid and bases. Of course, the proper uses of the acid and base will be starting in the respective chapters of HCl, HNO3, ammonia and H2SO4. So here they are given the basic reaction of the acid and bases to form neutralization. So we can just understand in a very short manner because we already gone through this thing. We know that acid plus base is going to give me salt plus water. So how does it form? Acid. We know that acid. Let's take HCl. So HCl is nothing but H plus Cl minus. A base. Let's take base as NaOH. So it is nothing but Na plus OH minus. So when you see this thing, what is going to happen? This and this are going to react to give you the resultant as NaCl, of course, and this one is going to give rise to what is water. So this is how the double displacement taking place over here is giving rise to the salt plus water. So during neutralization, the hydrogen ion or proton from the acid is neutralized by the hydroxide. The hydrogen plus H plus ion of the acid is getting neutralized by the OH ion of the base. Okay, so is neutralized by the hydroxide ion of the alkali to form water. A water molecule H2O, thus HCl donates H plus ion, that is a proton, to OH. So here Cl is going to take away the chlorine, and here it is going to be the so take away that part and enter Cl minus, OH minus, C plus already दे दिया था, तो that's why this ions were already formed. This was not formation of ion was already there. This was Na plus and this was Cl minus, so they are combined together. So here Na doesn't give anything to this thing. Na is already given it to OH. H gives away its electron to Cl. So that's why Cl is negative. So this positive negative frames this acid, a salt, and water formation over here is OH minus plus H. Okay. So it is proton going to OH over here to form H2O. So thus HCl donates a hydrogen ion proton to the OH ion of NaOH, which accepts the proton, forming water. Heat of neutralization, the amount of heat liberated when 1 gram of equivalent of acid or base is completely neutralized is the heat of neutralization. So the amount of, see, this is going to be a exothermic reaction. So when the amount of heat which is going to be given out over here is called as heat of neutralization. So that was about the properties and formation of acids and all. So we stop here for this particular video, and we continue with the indicators in the next video.